Hi, this is Tim Urdan, author of Statistics in Plain English, and in this video I'm going to go through how to use SPSS to generate a factor analysis and then how to interpret the factor analysis. So I've got a data set here, and this is a group of high school students that I've collected data from. And one of the things that I asked these students was about some motivational characteristics, and I asked them about their goals, two different kinds of goals, what's known as performance approach goals, and this is a desire to do better than other students, the goal of being the best student in the class, outperforming others, things like that. And then there's performance avoidance goals, which is the goal of not doing worse than others, avoiding appearing less able than others, or ineffective and in school. And then I also ask questions about intrinsic motivation. These are questions like, I think this schoolwork is interesting, I think I enjoy my schoolwork, things like that. And one of the things that you can do with a factor analysis is you can see whether variables or constructs that you think are separate, like performance approach goals, performance avoidance goals, intrinsic motivation, you can see if students' responses really did treat those questions as separate. So for each of the constructs, performance approach goals, performance avoidance goals, and intrinsic motivation, we asked several survey questions, and I'm just going to use 3 from each of those. So here's how you would do this in SPSS. You go to Analyze, and it's called Dimension Reduction. This is where you want to reduce several items and put them into single larger factors. So it's a way of reducing your data. That's why it's called Dimension Reduction. And I've already selected the variables, so we have App1 means one of the performance approach goals. So as an example, it's important to me that I look smarter than others. Here's an avoidance goal. I do work so that others won't think that I am stupid. And here's an intrinsic motivation goal. I'm enjoying my English class. We ask these questions in students' English class. So there are 3 approach questions, 3 avoidance questions, and 3 intrinsic motivation questions. So these are the 9 survey items that I'm going to include in my factor analysis. And then there's some options. I'm going to get descriptive statistics, so I get some information about the mean, standard deviations, and the sample size. There's a lot of other things that you can ask for. I'm not going to look for those right now. The extraction has a few different options. We're going to do a principal components analysis. There's several others: unweighted least squares, generalized least squares, maximum likelihood. Actually, maximum likelihood is a good one, but we talked about principal components in the chapter, so let's do one of those. We're going to analyze the correlation matrix. Other option is to analyze the covariance matrix. And I'm asking to display the unrotated factor solution. Let's get the scree plot too. That's kind of interesting to look at. And then you have your choice. You can have it, the program will select factors for you based on eigenvalues if you want to, and you can set what the level of the eigenvalue is that you want for each factor, or you can set a fixed number of factors. So let's start by just seeing how many factors do we get that have an eigenvalue of greater than 1. Remember, these items that I've included are supposed to be measuring 3 separate constructs, so I'm expecting 3 factors to emerge, each with an eigenvalue greater than 1. That's what I expect. For rotation, we'll use the Varimax. This creates the maximum separation between the factors. And I want to see the rotated factor solution. And then there's another option about how to save your factors if you want to. But in options, you can decide how to treat missing values. I'm excluding cases listwise, so Each of the items in my factor analysis will have the same cases. I want to sort the results by the size of the factor loadings, and I want to suppress the small coefficients. So any loadings that are below 0.30 will not show up in my factor, my rotated factor matrix or my unrotated factor matrix. This just makes it a little bit easier to interpret the output. So I'll click OK, and I'll let SPSS do its work. And here's what we get. First, we get the descriptive statistics, and this shows the means for each of the variables in the analysis, the standard deviations, and the sample size. Sample size is 855, and that is for each of the items in my analysis because I selected list-wise deletion of missing data. The scree plot shows the eigenvalues. So we see we've got one factor that has an eigenvalue above 3. We have another one that has an eigenvalue above 2, and then we have one that's a little bit below 1, and then a bunch of other ones. You get as many factors as you have items in your analysis. So there's 9 items in the analysis. That produces 9 factors. But most of them aren't providing a lot of meaningful information. So some people use the scree plot to decide how many factors should I keep. This suggests that all of these are from 4 through 9 are not providing much information. So it's a question of whether I keep 2 factors or 3. Pretty big drop off between 2 and 3. Now if we scroll down here, we get the component matrix, and this shows loadings of items on the different components. You'll see that these are all blank here because these all have loadings of less than 0.30. Communalities shows the relationship between each item and the factors. Is basically how much of the variance in each of the items is explained by the factor analysis. So this one doesn't have a lot of variance explained. This one has quite a bit. That means this item is probably not going to load strong on any of the factors. Okay, total variance explained. This is where we see our how much of the variance was explained by each of the factors, and we see that it kept 2 factors because we only had 2 factors that had eigenvalues of greater than 1. And the first factor explained, let me click on that. The first factor explained 34.95% of the overall variance in the items in the factor analysis. The second one explained 25.21% of the variance. In the 2 factors together explained 60% of the variance in the items. And then this is what we look at to really interpret our factors. This is the rotated component matrix, otherwise known as the rotated factor matrix. And it shows you the separate factors. We've got 2. And this factor number 2 is all 3 of the extrinsic motivation items. So the extrinsic motivation items separated out as their own factor, meaning that they were answered differently than the approach and avoidance goal items. All of the approach and avoidance goal items loaded together on a single factor. So in the research, it says those should form 2 separate factors, that wanting to do better than others is really a different kind of motivation, a different kind of goal than wanting to avoid performing worse than others. But students in my sample didn't interpret the items that way. They answered them similarly. Remember, factor analysis is based on correlations, and this means that students who answered, say, this item in a certain way, say they circled a 5 on the scale of 1 to 5, means that they answered this item and this item and this item all in similar ways. It doesn't mean that everybody answered gave the same response to the item. It means that students who answered one of the items in a particular way answered the rest of these items on this factor in similar ways. Their responses on these 6 items that are in factor 1 are pretty highly correlated with each other. And these loadings are all pretty high. The smallest loading is 0.660. So it looks like it's going to be a pretty strong factor. Now, theory and prior research says that these 9 items should form 3 factors. So I'm going to see what happens when I force SPSS to create 3 factors. And here's how we do it. We've got the same items, and this time, let's see. Not that. Sorry, I forgot. Oh, here. In the extraction option, instead of letting it form factors based on those with eigenvalues greater than 1, I'm going to select a fixed number of factors, and I'm going to select 3 because that's how many factors I expected. So when I do create a 3-factor solution, what do I get? It starts with descriptive statistics again. Same scree plot. Now we've got 3 factors in our component matrix. This is what goes into the factor analysis. Communalities, total variance explained, and now we can see this 3rd factor explained an additional 10.541% of the variance. So that's not bad. I mean, that's a factor that explains 10% of the variance is worth considering keeping. Now let's look at the rotated factor matrix and see what's going on. First, this factor, factor 2, with the 3 extrinsic motivation items, that stays about the same. These 3 items load with each other, but not with on the other 2 factors. Notice that this loading is negative. That's because this item is worded negatively. So the first 2 extrinsic items in this factor are both about enjoying class, thinking it's fun, and this one is about thinking that English class is a waste of time. So it's asking about intrinsic motivation, but it's asking about the opposite, and that's why it's loading negatively. But it is still highly correlated with the other 2 extrinsic items, suggesting that all 3 of these items go together well. The first factor, which used to have all 6 of the avoid and approach items, now has 4 of them. And it is 3 of the avoidance items and 1 of the approach items, which loads pretty weakly on it. And then the 3rd factor is 2 of the approach items and the 3rd approach item, which is actually cross-loading on these 2 factors. So what this tells me is maybe students are separating approach and avoidance somewhat, but there's one approach item that is not clearly distinguishing between approach and avoidance, and is therefore probably not a really great item. Doesn't seem to be measuring either one very clearly. So I would consider dropping this item. And then I would also look at, well, what is the item and how is it different? This one says, it's important to me that I look smarter than others. The other 2 items in the approach scale were wanting to do better than others and successful if I did better than others. So these 2 items are about actually performing better than others. And this one, the one that's cross-loading, is about looking smarter than others, which is a little bit different. And the reason it's loading on the avoidance factor is because this also has some questions about how you look. This one's about looking like I know how to do well on tests. This one is about avoiding looking like I have trouble doing the work. So really it seems to be separating these factors based on wanting to outperform others versus wanting to look smart or avoid looking dumb. So I think that I would be tempted to drop this performance approach item and then maybe keep a 3-factor solution. But before I did that, I would want to conduct a reliability analysis to see whether the items on the 3 factors hold together and form a reliable scale. So that is how you um, use SPSS to perform a factor analysis, and that's how you interpret the output. I hope that's helpful.